Alright, next example, a light rope connects two blocks with mass 3 kilograms and 5 kilograms and slide on a frictionless surface as shown. A force F of 10 newtons acts on M2 at 20 degrees with respect to the horizontal. Find the acceleration of the system and the tension in the rope. Okay, so first is we're going to understand that the connection of two blocks M1 and M2 are in a series form, meaning to say the movement of one block would still, or I mean, the movement of one block is the same as the movement of the second block, or the distance traveled by the first block is equal to the distance traveled by the second block. Therefore, the velocity of the first block is just equal to the velocity of the second block, and its acceleration of the first block is just equal to the acceleration of the second block. So in this case, we're going to find the acceleration of the whole system and the tension connecting between the first block and the second block. So, mo ni ang tension nga naa diha. So we're going to find that one. Okay. So as it said, it's said in the problem that there is I mean, all the surface is frictionless, meaning to say we're gonna neglect the principle of belt friction here. No, so there is no tight side and there is no slack side. Hence, the tension on the left side of the pulley is just equal to the tension on the right side of the pulley due to its frictionless form. And then we are going to get or consider the free body diagram of each block. So starting with free body diagram of M1. So what is M1? M1 is inclined a certain angle 30. So we're going to incline that one. And then of course, you're going to observe this line. You can apply it here. And just to indicate that this is its form. Okay. So it has a mass, which is 3 kilograms, or if you're gonna multiply 9.81, that's 3 times 9.81, 29.43. 29.43 newtons. Kana siya. And then there is an action of the force, so therefore the motion is considered to be moving here. This is the motion, and this is the acceleration. So if that would be the acceleration, then the REF would be found here. So this is the REF of the first block, because there is an REF of the second block as well. And then we're gonna apply the tension, or the T, or the tension. I'm gonna use T as the tension because all throughout the cable, the tension is the same, or equal, or constant. Alright, so with respect to the inclined surface, we're gonna get the component of this 3 kilogram block. So this is 29.43, and this is the angle 30, no? Kana siya, this is angle 30 na siya. So this is 29.43 cosine 30, and you have also here, this is 29.43 sine of 30. Okay, so by this principle, all we have to do is get the tension so we can proceed and transmit it to the next tension, which is found there. So gonna have summation of forces vertical on the shifted axis. By the way, there is a normal force N. Should we need to get the normal force? I don't think so na, no? Kay there is no friction man sad. So therefore, pwede na nato dili i-consider ang normal force. So we can immediately proceed in doing the summation of forces horizontal on the shifted axis. So to the right positive, to the left negative. So starting with the tension. So that's equal to 0, by the way. Delete. And this is to the right positive, to the left negative. You have the tension, the T to the right. What else? You have the 29 sine, no, that's minus 29.43 sine of 30, and then minus the REF number 1, and that's equal to 0. So we're gonna proceed in expounding the REF. This is equal to 29.43 sine of 30 plus, no, we're transposing all the terms except T to the right side. So you have REF, which is the weight of the first block over the G times the acceleration of the first block. So you have T, and that's equal to 29.43 sine of 30 plus 29.43 as the weight divided by 9.81 times the acceleration of the first block. Anyway, acceleration of the first block is equal to the acceleration of the second block, or the acceleration of the whole system. Okay, so this is our equation number 1. Next is we're gonna proceed in getting the how we call this one, free body diagram here. But first, let's proceed first with the free body diagram of the pulley. So I just wanted to highlight that this pulley bears no difference in tension, diba? So here, ako lang i-emphasize para at least this is the tension on the left side, which is T1, and that's equal to T. And this one is the tension on the right side, which is equal to the T2, or just equal to T. So again, they're both equal. T1 and T2 are just the same because this is frictionless. Okay, so that's frictionless. So let's now proceed with the free body diagram of the second block of mass number 2. No, so free body diagram of mass number 2. So we're gonna draw this one, the block number 2. Okay, and then there is an applied force F, and with respect to the horizontal, so this is, how much is this one? 20. So according to problem, it's 20. So this is 20 degrees. And then there is a tension, no? Tension is found here, pointing away from the system. So that's T. And then the movement, no? The motion is towards there, together with the acceleration. So therefore, the REF is also, so I'm gonna place REF here, REF number 2, no? And then it has a mass of 5 kilograms. So that's 5 times 9.81. 5 times 9.81. That's 49.05. Okay, so I'm gonna transfer this one here. Okay, and then the force, do not forget, this is inclined at a certain angle, so we need components. So this is F, which is F equal to 10. So this is 10 sine of 20, and you have here 10 cosine of 20. So of course there is normal force. Do not forget that. There is normal force, but we don't need normal force because there is no friction. So F is just equal to 0, or friction is equal to 0. So makancel out na siya. Okay, so what we're gonna do now is do the summation of forces horizontal, and that's equal to 0. So you will have to the right positive, to the left negative. So to the right is 10 cosine of 20, and then minus, you have REF, or tension, and then minus REF number 2, and that's equal to 0. So we're gonna transpose this everything to the right side, so it will become 10 cosine of 20, and that's equal to the tension plus the REF number 2. So what is tension? Tension is this one. So we're gonna substitute that there. So this is 10 cosine of 20 equal to the tension. This is tension. This whole thing here is the tension. And then plus the REF number 2, which is the weight. No? So this one. Weight of the second block over 9.81 times the acceleration number 2. However, acceleration number 2 is equal to acceleration number 1, or the acceleration of the whole system. So I'm gonna rewrite. This is 10 cosine of 20. That's equal to 29.43 sine of 30. Then plus 29.43 over 9.81 times the acceleration plus the W2, which is 49.05, divided by 9.81 times the acceleration 2, or just acceleration. So collecting like terms, we're gonna have acceleration, no? Acceleration equal to, or i-factor out na to, that's 29.43 over 9.81 plus 49.05 divided by 9.81, and that's equal to 10 cosine of 20 minus 29.43 sine of 30. So that would be this one, 10 cosine of 20 minus 29.43 sine of 30 divided by 29.43 over 9.81 plus 49.05 over 9.81. So therefore, the answer is acceleration equal to negative 66.5. So this is 0.0.665 meter per square seconds. So this negative sign here indicates that direction is opposite, and therefore it is deceleration. So you have 0.665 as the answer. And let's solve for the tension of the cable. So we're gonna use this one because this is the tension. So gonna have this, solving for the tension. And then we're gonna substitute the acceleration. This is 29.43 sine of 30, then plus 29.43 for 9.81 times the acceleration that we're gonna substitute is negative 0.665. Ang reason nga nung negative 0.665, negative itong answer because this acceleration is obtained from an assumption that it's going up, no? Going to the right. So somehow we obtain a negative answer, then therefore this one must be corrected, no? So the tension here is 29.43 sine of 30 plus 29.43 over 9.81 times 0.665. This is negative. That's 12.72 newtons. And this is the tension of the cable.